In this video, we're going to look at how to expand binomial products when we have surds involved, when they are irrational numbers. Before we do that, let's just quickly revisit what we already know about expanding binomial products. So this is a product where we've got two terms in the brackets. So what you would remember is everything inside the first bracket has to get multiplied by everything inside the second bracket. So to expand this one here, we would say we would have A times C here, plus A gets multiplied by D over here. Then we would have B times C, and we would have B times D. Then you would look to see if you had any like terms and you would group them accordingly. There's none here. I've just done this as an example so you can see what term gets multiplied by what. So if we have a look at these examples here, if I have two brackets multiplying by one another, the same process is going to happen as what we just did then. So I'm going to look at A times A, which is going to be A squared. A times minus B gives me minus AB. Then I've got B times A, and they're both positive, so I've got a positive AB. B times minus B gives me minus B squared. Now what you'll see here is my two middle terms will cancel out. I've got a minus AB and a plus AB. They cancel one another out. I end up having an A squared minus B squared as my final result. This is what we call a difference of perfect squares. Which gets shortened to difference of perfect squares, DOPS. The signpost that you're looking for a DOPS is that you've got two brackets, both have the same terms in it, but one has a positive, one has a negative. And what will happen as you expand is your middle terms will always cancel one another out. A difference of perfect squares. Let's have a look at these two examples down the bottom. These are what we call perfect squares because we have the one bracket and it's multiplied by itself. So let's write that in expanded form. Oops. Times by itself, A minus B times A minus B. Using the process that we used up here, I'm going to get A times A, which is A squared. A times minus B, which is minus AB, minus B times A, which is another minus AB, then minus B times minus B, which is plus B squared. Now what we've got with our middle terms is we have a minus AB take away another AB. So we're going to have this AB is actually there twice. I've got minus 2 lots of AB plus B squared. I've got a minus 1AB, take away another AB. I've got a minus 2AB. Let's have a look at this one. If we've got the same problem but I have both positives, I'm going to end up with A times A there, A times B, another A times B, and this one will be a B squared. So I have A squared, 2 ABs, and a B squared. Have a look at the patterns here. Have a look at what happens when we expand perfect squares. As you would expect, let's just move that up there so we can see it. When I expand here, the temptation is to say, well, I've just got A squared and I've got B squared, and you forget about this middle term. Similarly here, if I've got A squared and B squared, certainly they play a part in the answer, but you can't forget the middle term. The shortcut to go straight from here to here is to look at your two terms. I have an A squared, I have a B squared, they make up the two ends. The middle term, I multiply a times b, the two terms in my bracket, and then I double it and it goes in there. A times minus b is minus ab, and then I double it. I get minus 2ab. That's a shortcut to go straight from there to there. Let's now apply these four different principles to binomial products involving surds. We're not going to treat them any differently. We're still going to go 4 times root 3 is 4 root 3. 4 times minus 2 is minus 8. Root 3 by root 3 is just a 3, because root 3 times another root 3, going the long way around, is root 9, and we know that the square root of 9 is then 3. Whenever you multiply a surd by itself, when we square a surd, it ends up just being the number that was under the square root in the first place. And then we have root 3 by minus 2, which is minus 2 root 3. All that's left now is to group things together. I've got 4 root 3's here, and I'm taking away 2 root 3's, so I have 2 root 3's left. And then I have minus 8 plus 3, minus 8 plus 3 is minus 5. So that would be my solution there. 2 root 3 minus 5. I've just done the colour coding there so you can see where everything came from. Let's have a look at this one. 2 root 5 by 3 root 5. Now the root 5 times root 5 is going to end up being 5. Then 2 times 3 is 6. 6 times 5 gives me 30. 2 root 5 times 4 is 8 root 5. Minus 1 by 3 root 5 is minus 3 root 5. And minus 1 times plus 4 is minus 4. Grouping everything together, I have 30 take away 4, 26. 8 root 5 take away 3 root 5 is 5 root 5. These weren't any particular special cases, they were just two random binomials that we multiplied together. Over here though, we're going to look at expanding our perfect squares and our dots that we went through on one of the previous slides. Here I have this binomial squared. The shortcut, if you remember, is that we square the first one, square the last one, and then for the middle term, multiply these two together and then double it. So multiplying them together, I have minus 2 root 7, and then when I double it, I've got minus 4 root 7. This one here is going to be a plus, because whether I square a minus root 7 or a plus root 7, when I square it, it's always going to be a plus. So neatening that up, I have 4 take 4 root 7 plus root 7 squared, which is 7. So 11 take 4 root 7 is my result. This one here, square the first one, 3 root 2 squared. Root 2 squared, actually I might just leave it like that and we'll expand it in a moment. Then my last term is going to be 5 root 3 all squared. To get the middle term, I multiply them together and double it. So I'm going to get 15 root 6. When I double it, I'm going to get 30 root 6. Now expanding everything, root 2 squared is 2. 3 squared is 9. 2 times 9 is 18. Plus 30 root 6. Plus root 3 squared is 3. 5 squared is 25. 25 times 3, 75. Then neatening it all up, 18 plus 75, 93 plus 30 root 6. Over here we've got expanding to form dots. Now as I said in the previous slide, what you're looking for is two brackets where the terms are the same, 7 root 2 in both, root 3 in both, but one of the brackets has a minus, one of the brackets has a plus. Same thing down here. One of them's got a plus, one of them's got a minus. It doesn't matter which one comes first. Okay, so to expand this, remember when we go back to here, when you've got one as a plus and one as a minus, that middle term is always going to cancel one another out. So we're just going to have the a squared and the b squared. Really quick, these ones, so let's do that. So I'm going to just have 7 root 2 squared minus root 3 squared, because that middle term is going to cancel out. Root 2 squared is 2, 7 squared is 49, 2 lots of 49 is 98. Take root 3 squared, which is 3. My answer here ends up being 95. This one here, 2 squared is the first term. The second term will be root 5 squared. 2 squared is 4. Root 5 squared is 5. My answer to this is -1. If you don't recognise the shortcuts here, it's not a big deal. You can go the long way and you're going to get the right answer, but the shortcut obviously is going to make it a little bit quicker. Good luck.